Good evening and welcome to the 2021 Ed Link Lecture. I'm Gordon Woolley and I've got the pleasure of hosting this evening's speaker. It falls to me because this is an open lecture, so we've got some people have joined us just for this to reiterate the housekeeping points. So there is no fire drill planned, so if we get the fire alarm, it will be a real warning, and the exits are where my beautiful assistant is standing at the back there or out this way, and the muster point is outside the Hotel Continental there. Please silence or switch off your mobile devices. Here, no smoking, obviously, and our speaker will talk for about 40 or 45 minutes, and then we'll be happy to answer questions at the end. So the EdLink lecture, as Chris mentioned earlier today, EdLink was at the first of these lectures, and the Flight Simulation Group hosts two named lectures a year, one in honor of Edwin Link. Although we have been unable to do it, it's a great pleasure to resurrect the, if I can put it that way, the EdLink lecture for this year. For the EdLink lecture, we take distinguished figures from civil or military world who have made or are making a significant contribution or have a significant interest in flight simulation generally. For this lecture, I've got great pleasure in welcoming Group Captain Paul Cole here. Now, as I was going through the exit door of the Royal Air Force a good few years ago now, Paul was coming in the indoor, and I've known him since that time. And since that time, he's had a distinguished and very successful career flying in command and in staff jobs. And he now finds himself at the front end of delivering a very ambitious vision for the Royal Air Force future flight training, the Royal Air Force up to 2040 or in 2040. Very ambitious designs for using synthetic training, flight simulators, and so on, and looking at the balance between the live and the synthetic. And that is going to be the subject of Paul's talk this evening. So please join me in welcoming the 2021 EdLink lecturer, Group Captain Paul Cole. Paul.
Brilliant. Thank you for that introduction, Gordon. And it's been so long since we first met that I'm probably going out the door of the Air Force as well soon. That makes me feel very old. So as Gordon said, my current role is the Assistant Director Plans in the RAeS Directorate of Flying Training. And it's a huge honor to be asked to deliver the Edwin Link Lecture this year. And as I'm sure everyone here knows, Edwin A. Link invented flight simulation, with many of the parts for his 1920s Link trainer coming from his father's organ factory. So that was highly innovative and very cross-sector. So perhaps there's lessons there for us all here today, a century on. In my role today, I'm very much standing upon his shoulders, and I hope he would be pleased to see how far we've all come and our level of ambition for the future. And hopefully what I have to say tonight will show how we're knitting a lot of today's proceedings together in a military context. So how is flying training delivered in the United Kingdom? In terms of the UK defence budget, it's a large chunk, demonstrating the importance our senior leaders, both political and official, attach to flying training. It's actually one of the few defence programmes that is also a major government programme, with all the extra scrutiny that brings. The plan was to introduce the new flying training system without disruption to operational output. A tall ask, and one we have, by and large, met. Our training service provider is a company called Ascent, a 50-50 joint venture between Lockheed Martin and Babcock International, with the sole purpose to provide the military flying training system for the UK's armed forces out to the year 2033. This leads us into a unique partnering arrangement with the Royal Air Force No. 22 Group and the UK MFTS project team from Defence Equipment and Support, the UK's MOD procurement agency, and Ascent. Very much a three-legged stool, utterly reliant upon each other as our successes and failures are intertwined, and we're only as strong as each other. Moving on to the key challenges we're facing today. Essentially, there are three. The introduction of new aircraft as part of the enduring legacy of the 2015 Strategic Defence and Security Review, the requirement to train more fast jet pilots, and as you'd all expect, resource. Taking each in turn. New aircraft. We've recently added 4 new Texan aircraft to our fleet and more helicopters, all to cope with our SDSR-15 increased demand for military aircrew, something the integrated review didn't really alter. Aligned with this challenge is that of an interconnected training pipeline. It's actually more like a web than a pipe. Pull on one part of it, making a change, for example, the Army Air Corps and the Fleet Air Arm going direct rotary wing, then you cause an effect valley on fast jet training, as now you have more prefect hours on fixed wing elementary flying training at Cranwell. The major challenge sits in the fast jet arena. Stand fast to current pause in airline recruitment. All the indicators, and we've heard that again this morning, are that this will not last and people will again begin to leave. Some we are certain have remained, not because they wish to, more because they have to. Whilst I personally will leave how we remunerate and look after our people to others, my part of the solution is to train more people more quickly so that they can spend more time on the front line, which is why we all join our nation's militaries anyhow. MFTS is such a success now that the problem is actually absorbing those personnel onto the front line. Lastly, the perennial issue of resource. We would all like more money, more time, and more people, be you in the government sector or the private sector. However, for all of us, it's simply unrealistic. And we in defence must be frugal with taxpayers' hard-earned money, giving them demonstrable value for money. And that means we have to be as efficient as possible in all that we do. So the key challenges demand solutions. And I've grouped my thinking into 5 areas: innovate, download, tech, and pipeline redesign, all underpinned by experimentation. Firstly, innovate. Google, Uber, Apple, Microsoft, and Facebook all came from meeting a demand with little resource, and now look where they are. Similarly, in defence, United States General Martin Dempsey believes it holds true. And in a recent RAeS podcast, he said he used this methodology as the chairman of the Joint Chief of Staff to drive innovation across the US Armed Forces. Stress is a great innovator. Witness the leaps in aerospace during the 2 hot and 1 cold world wars. And indeed, how this conference is now being run in a hybrid fashion and how we've all worked for the last 18, 19, 20 months. Download is key. I need to download from Coningsby to Cranwell, get the training out of expensive frontline aircraft and backwards as far as possible through the training journey. I need to download from cockpit to computer, get as much out of noisy, expensive, CO2 emitting aircraft into synthetics that can run on green electricity to help meet this nation's net zero 50 targets and my chief's net zero 40 target to make us not only the world's first air force, but the world's first net zero air force. I need to download from classroom to chat room to allow students to practice as much as they need to, perhaps even arriving at the next stage, having completed all their ground school and more virtually. I need to move from instructor-led to student-demanded, modern learning for modern minds for Generation Z and Generation Alpha. On-demand learning seems to be the format that meets their learning style and their needs. This will allow us to compress in time, training, so to get more frontline time per person, with Nirvana being a bespoke, targeted training course per individual student, only flying to confirm. So to try and turn these solutions, which look very attractive on a huge PowerPoint slide, into reality, we have 2 big tech projects ongoing. The first with our training service partner, Ascent, and the other through DSTL, Defence Science and Technology Laboratories, with RAeS. Fast jet training transformation is about getting the right number of student pilots to Hawk so that enough graduate to service the flying and staff roles required by the Royal Navy and the Royal Air Force. Driven by financial reality, we broke it into 4 segments across the financial years. Also, even if we had the finance, this was the sensible programmatic way of phasing it, as we had to keep the flying training system going. No luxury of an off-season to regroup and reset. So the sprint trials and video. This was using 2 of CAE's sprint devices, which in this case emulate the Texan T6, our basic fast jet trainer. We've experimented with downloading from our scarce and more expensive flight training devices. As the pace of tech moves on, even during the experiment, as we can see, the virtual headsets became more and more capable with wider and wider field of view and high resolution. Mixed reality came available. The headsets became lighter and more comfortable to wear. These trials are showing that there's the very real possibility of downloading from more expensive FMSs and allowing the students closer to an on-demand learning experience. We've experimented with linking up the 2 devices to fly formation and basic fighter maneuver, increasing sortie complexity and inducing a larger cognitive load upon the student. It also comes with eye tracking, so we can see where the student really is looking versus where they claim they are looking. And I personally was guilty of that in flying training, of fixing my eyes on the AI and not getting my head out of the cockpit. It also has virtual instructor modes, and we've found that the VR playback is very useful as a teaching tool for the QFI to demo what good looks like, and also for student debriefs. So I said these were trials, and trials they were. So using Central Flying School expertise in the form of Dr. John Alsop, a qualified psychologist, and his academic colleagues from Birmingham University and DSTL, we took a true scientific approach to inform our investment opportunities. Essentially, in a double-blind experiment, we assessed how well students learnt using the mixed reality sprint equipment versus the far more expensive and scarce FTD2 for the Hawk that we have. Now, it's late in the day, and I don't want this to be an eyesight test. So what I'm now showing is the scoring of students flying an ILS, having learnt and practiced the task in either the VR rig or the FTD2. So what we can see, and for context, a 3 as a pass, is that irrespective of the platform used, everyone passed. On balance, we can see that those using the more sophisticated system did a little better. So what do we believe this means? What's the so what? We believe VR is a useful addition to Texan synthetic training. Training in the more sophisticated device leads to better outcomes, but an increased cost. So to my mind, the so what is that the VR cannot quite yet replace the more sophisticated device, but that it is certainly complementary, and we could download some lessons further. I did qualify that comment by saying yet. And I also note that some companies are now offering motion platform VR rigs, which we're keen to explore the utility of. On video, we're finding this works really well with students also. So without putting you on the spot and asking you to decide which is a real video and which is taken from Sprint, the capture on the left is from a real flight. That on the right is from a VR simulation. With the difficulty in obtaining representative video capture of critical stages of live flight, for example, short finals, low level, close formation, basic fighter maneuver, the simulation offers us a safe opportunity to capture it, reducing the risk for the duty holder chain and those actually flying the aeroplane. And with an accurate enough landscape, the teaching benefit is plain. So prefecture Hawk trials. These are exciting and show how capable our people are and how capable the prefect of GROB 120 TP in civilian speak is. It can now take people far enough that they're ready to go straight to Hawk, bypassing Texan. So far, the trial's looking promising. The students are doing well on Hawk. For both aircraft types, the total hours have increased. But what we mustn't forget is we've saved all the Texan hours. So the net result across the system is a cost and carbon reduction. Synthetics are helping here to help reduce the risk by allowing the better, richer use of the live flying hours. To make prefect even more capable, we're looking at modifications that could include carefree throttle handling, pressurization, increased all-up mass, and more synthetics. Hawk trials. So, like much of my school science career, which is why I turned to the social sciences, not every experiment succeeds. And to explore the boundaries, we have to be given the space and be prepared to fail. The Hawk 360 video trial showed that the video does not currently have sufficient resolution for basic fighter maneuver, let alone for advanced combat maneuver. The picture we're looking at shows a bunch of yachts at 1 nautical mile. I'm not a fast jet pilot, but even I can work out that resolution is not good enough yet to work out closure, plan form, or range assessments. However, we've parked that. We'll monitor what's out there in industry, and we'll reassess when the resolution surely improves. The VR for the Hawk is looking a lot more promising, and we're building that upon the work already done on Texan. Plus, using the VR work we're currently doing on Hawk to support Qatari Emirati Air Force students coming across the UK flying training system, both with learning how to use English in the aerospace environment and then getting them used to flying in clouds and mountains, both of which not terribly available in Qatar. On Hawk Mixed Reality, the next step is to do that, introducing it to the desktop trainers and enhancing the flight model for the simulator to make them more representative of the aircraft. So we can again download more out of the air onto the ground. I have to download 1,500 Hawk hours by 2023. Again, our plan here is to use these cheaper systems in bulk, allowing lots of on-demand training for the students. They can come and use it when they want, how they want. Once we've completed this experiment, then again, like school, we'll be back to writing up and the so what discerned. And in this case, the output will be a next generation flying training system, with the outcome being more, better trained pilots hitting the front line. IDAS, Immersive Data Driven Airmanship Simulator. What's really clever about this kit is it's lightweight and portable. It goes in a suitcase. And then when you get it out, it fits around a normal office chair, as you can see with our previous Royal Canadian Air Force exchange officer using the equipment. The point is to codify airmanship. All of us know it when we see it, but what is it? And this project aims to show us that, and also what it looks like at each stage of a career for each type of a pilot. So working with aero-based RAeS through DSTL and RF experimentation based at Royal Air Force Leeming, we're using a Texan-based rig to capture vast amounts of data, which can then be exploited so we can codify airmanship, or at least start to. And this is where we're just starting to use AI, big data, and machine learning to help us. To be honest, we're very much in the foothills, but the opportunities seem to be there. And our close friends, the French Armée de l'Air and de l'Espace, are starting to use e-gaming in their pilot selection. So again, we can see that IDAS offers such opportunities for us. I've listed some of the benefits here. Some are more high level, related to the MOD's high level defense science and technology strategy and HM government's leveling up. What we and I want is to have an ability to spot when a student moves from system 2 to system 1 thinking, as that's when I can truly load them up. Working out what airmanship is, and also starting to work out the answer to the question of what is the optimum live synthetic balance. Noting that as synthetics change and improve, that ratio itself will likely change. And if this helps us get the selection right, with the eye-watering costs of training an F-35 pilot quoted at approximately $100 million US, the fact that we have to train UK, US eyes only F-35 sorties in the synthetic environment because we don't wish to demonstrate to the rest of the planet how formidable that platform is, we're going to have to use simulators. Another strain to this is pipeline change. Historically, we've had a fixed pipeline of elementary, basic, and advanced, probably going back to 1912 when we first established the Central Flying School. And this pipeline was irrespective of where you were destined and how good at flying training you were. Today, we need to step away from that fixed system to one that is more agile, more tailored to the individual and their frontline role, and then it's far more efficient. Because what we in training need to remember is that it's not an end in itself. For us, it's about military capability. So we're going to create multiple pathways through the training system, use the aircraft more intelligently. So for example, on multi-engines, my background, some of the training will finally be tailored towards ISTAR, tactical air transport, strategic air transport. The same is going to happen at Shawbury for helicopters. For fast jet personnel, that means you'll do parallel pathway. You'll either go prefect to Hawk, or if you've come through the University Air Squadron system, you'll go Texan to Hawk. The next step will be proficiency progression, and eventually fly to confirm. Quite a break from the past, but one that with simulation, I truly believe is now possible. But what for the day after tomorrow? And for me, that's looking out 10 years hence. And the areas I want to discuss are Astra, foreseeing changes, recruiting challenges, the scale of international cooperation, and finally, what opportunities we have. Astra is about the next generation Air Force, looking towards the middle of this century and the advent of Generation 6 platforms such as Tempest. It's also about challenging how we do things, shifting training to just-in-time, shifting to synthetics. So what changes do I foresee for flying training? We've all here tried to predict what will happen, but the last 20 years have seen an unprecedented technological advances in many areas, so much so that we're now living through the fourth industrial revolution. There's nothing to suggest this advance will slow down, and therefore we must keep pace and look for openings to maintain our advantage over adversaries. The most significant changes and advances are likely to be in the synthetic arena, with target levels provided by the RAF's Astra vision to radically change the live synthetic balance to 2080 by the year 2040. So 80% of training delivered synthetically. We're already partway there. The A400M conversion at Bryce Norton is currently 90% synthetic. The key to all this will be getting our synthetic environments to be more representative. They must incorporate high-end visuals. They must be networked. They must provide realistic ATC, and they must generate other air entities, either human-controlled or via AI. And that's going to be required to make our people better, faster. However, there's likely to be unintended consequences of such a move. It may generate different errors, but possibly not more errors. For example, think about cognitive emergency actions. Real in the FTD, with levers moved? Will that lead to real actions in the live air system in response to a simulated emergency? We'll have to think about these carefully. The MOD's Integrated Operating Concept 2030 indicates a greater mix of crewed, uncrewed, and autonomous systems. uncrewed and autonomous systems will be different from RAeS. We're going to have to consider who will control these systems and how will we train for them. Is it feasible to have a single controller for multiple systems? Will there be an appetite for non-human cargo flights to be uncrewed, or even human cargo flights to be uncrewed, like the London Docklands Railway? A particular challenge for the Royal Air Force is a service-wide relative lack of SQEP modelling and simulation expertise and deep cyber knowledge generally, to ensure that the synthetic usage is maximised appropriately and such systems are specified and procured properly. And we need to foster growth in this expertise. Data is the new gold. The world revolves around it and it has worth, but it needs managing. We need to use the data generated by our complex platforms and simulators to tailor the flying training experience to an individual. We need to use that data to improve 3 key aspects of flying training: safety, quality, and efficiency. And we need to use data to work out the optimum live synthetic balance using performance data, not just blunt targets. So the risks. Fidelity, to my mind, covers all aspects of the sortie cycle, not just the flying. So the question is, will training in the synthetic environment be more operationally representative compared to the live? And I've already given one example of F-35, where we cannot rehearse all missions in the air. But before we leap this way, we have considerations. Who's the audience? Rotary, fast air, transport, rear crew, air traffic, engineers, operations support staff. They're all key to delivering air combat power. The whole, a sortie is a small part of several overlapping operational processes. They all need to come together to test the live system. Weather, fog into some viz, sync-on finals, and so on. We'll be able to emulate that accurately, especially in the low-level environment. Physiological, how do we emulate G? Typhoon is a 9G platform. You're not going to replicate that physiologically in the simulator. Air sickness, especially if down the back of a Poseidon or a wedge-tail in a metal tube with no windows rolling around. How do we make sure we haven't trained highly expensive non-commissioned aircrew and then find they can't cope with being in the back of the jet? Other considerations: practice seat checks for those on ejection seats, practice aircraft walk rounds, practice donning of air equipment assemblies, and especially if we go back to an NBC scenario where we have to fly an NBC equipment. And then what should we keep for live flying? Should we go deep and narrow, or should we go shallow and broad? Should we be thinking 5 hours or less a month for our frontline pilots? We'll most likely continue to attract applicants, but are they going to be the people we want, or far more importantly, the people we need? We here, most of us, are the products of different era and system, and it's difficult for us to be unbiased when we consider who we think should be operating the next generations of air systems. Can we, should we, try to identify recruits earlier? And as we touched on earlier, can we use the same synthetics to help identify and differentiate future aircrew more accurately and earlier? Applicants will likely still be products of a standard classroom-based national education system, and therefore early selection metrics will remain critical and may require development. We can also assume there will be a different set of demands for future combat air systems when compared to multi-engine and rotary systems. We can see with Tempest, the UK's Gen 6 combat aircraft programme, that the roles and demands on the operator are likely to be changed markedly. We're even seeing that with F-35, a simple aircraft to fly, a very difficult aircraft to operate and to fight. To maximise our talent, we need to continue to address equality and diversity so that we recruit the very best, irrespective of gender, colour, heritage, or belief. We have much more to do, and we need to understand why some do not believe that their Royal Air Force is a career for them. Of note, the percentage of females in the Royal Air Force combat air roles has not represented the overall pilot intake, and we need to get at why that is. The scale of international cooperation, and there's two aspects to this topic. The UK being a contributing member of an international venture, and the use of irreducible spare capacity within the current UK military flying training system. Retaining both avenues allows for absorption of the invariable variations in demand, and future uncertainty is probably the only guarantee that we have. International cooperation for flying training amongst NATO and other allies will be an insurance policy for all, but comes with a price tag. However, organic flying training systems may become unaffordable for some, and cooperation may be the preferred option. Common types may permit initial cooperation, but longer-term usage may require divergence. There's no Typhoon School. There never has been. Why not? Should there have been? Where will UK F-35 and P-8 training be conducted in 2035? The UK, Australia, USA? And what about Tempest? But there's opportunities. And uncertainty allows us the opportunity to think unbounded by current reality. A course of 14 trainees going through is unwieldy. They require a lot of instructors, briefs, and one-on-one time. And they progress at a pace dictated by facilities, not by performance. In the future, a trainee could arrive, be given the technology and the access, and start their journey, but with well-defined progress steps. FTDs running 24/7, events booked automatically in response to an individual completing online modules. Attitudes to instructional approach will also need to change, loosening the reins in some areas, tightening them in others. Tertiary education in this country is showing us the way, and we need in defence to have the humility to learn. Less reliance upon instructors, less reliance upon live air systems. No weather impact in the simulator unless you want it. Fewer choke points in the system. Competency-based progression. The generic synthetic air system could be used, which morphs into a more demanding system as the course advances. We could move to no conversion or simply a 2-week ground school. So there's lots of potential for time reduction, asset cost reduction, manpower reduction, and standardized delivery. It's got to be holistic with both aircrew physical and mental conditioning taken into account. Do we also need to be concerned about the motivation and the individual enjoyment, the life of a pilot, against treating them as a commodity? There's going to be difficult choices ahead. But the father of simulation, Edwin A. Link, would recognize these opportunities and challenges, I'm sure. And I know, having spoken with my late grandfather, who flew on the Stirlings, how skeptical that generation was of the box. The skeptics are still out there, even though the box that Edwin invented is getting better and better, and we must download. So I truly hope that if Edwin's here tonight with us, he will be proud of what he has started and excited of what all of us, be we military, civilian, on what part we play, are all doing with his invention. We in defence must continue to embrace it so we can defend the nation and protect the planet. Thank you. Yeah.
Ladies and gentlemen, thank you very much. Paul is very happy to take questions. The format will be, if you would use the standing mic over on the side there, please introduce yourself and direct your questions. I'm not going to moderate this, so
thanks.
So you're on your own. Right. So please, can we have the? I see a regular customer, Hardy Annual, heading towards the microphone. Ian Strawn.
Yes, hi there. Ian Strawn, an ex-Royal Air Force QFI. I wonder how you're going to sustain morale, particularly amongst the UT fighter pilot community. I can understand with transport aircraft, you do most of the work on the simulator, but then they have an operational role, so they have lots of real flying. Fighter area is just slightly different, it seems to me. And fighter pilots, and having been one myself, are a bit, I'm not quite sure the word, mercurial. You know, they want certain things, which include flying and high G and all the rest of it. And I can see from a training point of view, lots of simulator, very little real flying. But I'm not quite sure how this is going to work, unless you have some spare cheap aircraft on the squadron that they can go and, shall we say, horse around and enjoy themselves with.
Sure, thanks for that question, Ian. So the Astra live synthetic balance that we're looking at is across the system. So it's not every platform must be at that. The chief does recognize that different platforms have different requirements. So from my world, the strategic air transport, let's be honest, the Voyager does, when it's in the passenger mode, pretty much the same as commercial airliner does. So we can move to a very high live synthetic balance. You're not doing 3D maneuvers. For fast air, absolutely, Ian, you're doing 3D maneuvers. My comment about the physiological aspect really plays into the fast air CADA. We've only got one centrifuge in defense up at Cranwell. We can't keep putting the entire CADA through there to keep them G tolerant when they need to be tolerant in the Typhoon to 9. So there's that. I think also there's a change. And when different generations join the Air Force, the generation before says, oh, it's brilliant in my day. Oh, we had the Changi slip, I got told when I got to Lynham in and out of Singapore. And as I was leaving Bryce Norton, I was going, oh, before 9/11, we used to go around the world. And this next generation have come on and they've done their bit and they've had their time and they'll tell stories. But my point is the generations evolve. And I think if someone said, even only 20 years ago, when we were first loading our pilots onto Predators based out of Creech in the USA, no one wanted to go and fly a model aircraft. It's a toy. Why do I want to go and do that? Today, we have absolutely no problems in recruiting for Reaper with Protector coming online. It's one of the most operational air platforms UK Defence owns. They are on ops 24/7. You go and talk to the guys and girls up there, they absolutely love their job. It's incredibly demanding. And we can recruit direct for RPAS pilots now without an issue. So I do think the coming generation won't know that once upon a time, everyone flew 40, 50 live hours a month. This will be their reality, that they're fighting the F-35 in the simulator because that's where they can fly the F-35 to its true capability. Stand fast the G and the physiological, because they won't be able to fly over the North Sea because we're not going to let them, because we don't want any adversaries, Russia and China has been identified, to see what we're up to. I think that's going to come. The challenge will be the physiological aspect. And at the moment, the recruiting statistics speak for themselves. We have no problem recruiting. And we're quite open with this new generation coming through of what their futures look like. And it will only go that way.
Thanks, Captain Paul, for a great presentation. I'm interested in your views, I suppose, of innovation. It seems to happen in lots of pockets, and we're seeing that even at this conference. So how do we, at a UK level, how do you join up what primes or subprimes, SMEs, universities? What's underway, and what's on your wish list in that regard?
Yeah, great. Thanks, Connor. Yes, we were speaking at lunch. I hadn't met Connor before, and Connor says, "Oh, I'm doing all this voice stuff." And I said, "Oh, well, I'm really interested because we're doing biometrics, but we're not looked at voice yet." transpires Connor's doing voice analytics with the British Army. What do I know? I'm only in the Royal Air Force. And yes, there's a problem. I think some of this technology has been moving on so fast. It's been a bit like the Wild West, and there's been lots of pop-ups. And I think a bit like VHS and Betamax, if I can use an analogy from my childhood, which dates me, some's going to work and some's not. There's going to be an element of Darwinism. Within defence, it is being looked at. We have the Defence Modelling and Simulation Centre at Shrivenham, the Defence Academy there in Wiltshire. There is a joint services publication, which of course I've read all of them from cover to cover. That tells me how I should be doing it. I haven't read it, and I've got some staff who have, thankfully, and we do our best. But the timeliness and the process can get in the way. So I think some of the challenge is making the cohering process fast enough and rapid enough that can keep up with the tech and the innovation. Because when you go to RAF Valley, like I was last week, and you're talking to the 22, 23-year-old students going through the system, they've got some amazing ideas. And they've got some amazing tech in their pockets and in their rooms in the mess, because they've grown up with this and they can see ways of joining those dots. So that is coming within defence. Where we branch out of the Department of State itself, DSTL are looking at that, Defence Science Technology Laboratories. They are linking in with academia, and there is an academic partnership going on. We personally are linking in through Dr. John at Cranwell on Central Flying School to link into Birmingham. So his paper will come out in a peer-reviewed journal. I'm not sure which one yet, but it will come out properly peer-reviewed. So we can engage with them. The US Navy are doing a lot of work with academia as well, to get into the behavioral science and the psychology part of it, as well as the technology side of it, because you've got the human as a machine and then you've got the machine as a machine, and how we link the two together. So we have a lot of work to do. I'd give myself a B- on a good day at the moment, to be honest and frank with you all, because I think when we can scale up, then we've got an amazing opportunities. And that's what within the Royal Air Force, Project Gladiator, if anybody here has come across it, I know a couple of TARLIS have seen it. And that's looking to link up all the frontline simulators and getting into the live virtual constructive. And then Nirvana will be linking those in with the Type 45s and the Queen Elizabeth carriers, and then linking that up with Warminster with all the armoured fighting vehicle simulators they've got down there. So we can go and do a full package in simulator land. And actually that takes a lot of pressure off, because, and again, Gordon and I were speaking earlier, and Ian was quite right. We get a lot of our trade because at the moment, as a truckie, parachutists, and they do have VR equipment, need to parachute. So I need to fly my Hercules for them to jump out the back of. So I get some of my flying there. When air-to-air starts being live virtual constructive and a Typhoon is £70,000 an hour, the math says go and do that in the simulator, people. So how do we get enough trade for them? So again, I think we're back to a lot of the second order consequences of, right, we're going to do everything in the simulator, and then the 16 Air Assault Brigade going, well, I need to do my training. And the JTACs, the Joint Tactical Air Controllers, need to do their training. They need to do a live drop to get certified. So we've got to put a live aircraft with a live bomb on it for them to call the weapon in. So I think we need to cohere it. Gladiator will get after that from the air domain. And then we're going to have to get defence to get across cross-domain, and that is UK Strategic Command, Joint Force Development, getting over MDI, multi-domain integration, and looking at how they train. We train for that as well going forwards.
Well, we were promised an ambitious and wide-ranging talk, and that's what we've had, delivered with great clarity and great authority as well. I don't think any of us would envy the job that Paul has at the moment. He's also very constrained at what he said. So I'm very relieved to say he has been, because it's a fairly sensitive time for defence and budgeting and that sort of thing, he has been very open with us and exposed a great deal of what is going on, and his impressions of it, what he's hoping to do with it. So I think an excellent Edwin Link lecture, a great choice of Paul. And if you'll join me again in thanking him, he will be, for those at the conference, he will be around tomorrow. So if you want to do any chest poking, he's...
Please do.
Yeah.
Might go unattributable on the stage.
Very receptive to that. So please join me again in thanking Group Captain Paul Cole, our Edwin Link lecturer. Thank you.
Thanks, Paul.